Okay, so we're going to look at estimating with scientific notation, and the first example we're going to do is from the last lesson where we were converting units using our unit multipliers. And we're going to show how we can estimate the final answer to this using scientific notation. All right, so first of all, we're going to do the conversion. So we've got 16 cubic miles, and we're trying to change that to cubic inches. So to get from miles to inches, we're going to have to use two unit multipliers because we don't have a unit multiplier for inches and miles. So we have to go to feet first because we know that there are 5,280 feet in 1 mile. And we know that there are 12 inches in 1 foot. So we have to use both of these to do this conversion. So we've got 16 cubic miles. So we're going to start by writing that. And if it helps you, you can write it over 1, just to make sure you remember this is in the numerator, 16 cubic miles. All right. Remember that cubic miles is kind of like miles times miles times miles. And so when you use a unit multiplier to make the miles, the cubic miles cancel out, you're going to have to multiply by that unit multiplier 3 times. So 16 cubic miles, we want to change it to, first of all, cubic feet. So we're going to use this first unit multiplier that changes feet and miles. All right, so I want the miles to be on the bottom, and they are already. But make sure that you situate the fraction, and you can flip it upside down or right side up. It doesn't matter for the unit multiplier because it just equals 1. The numerator and the denominator are the same value. So I'll multiply this by 5,280 feet over 1 mile. All right. This is not going to cancel the cubic miles because the cubic miles, remember, is miles, miles, miles. This is just miles. I need miles, miles, miles. So I have to do this 3 times. Now the 3 miles will cancel. Miles, miles, miles on the top and the bottom. All right, now I need to get to cubic inches because that's what the problem is asking me to do. So now I will change from feet to inches. Here is the unit multiplier I need to do that. So I will put the 12 inches on the top and I'll put the 1 foot on the bottom because I want the feet to cancel. And I've got feet on the top, so that means I need feet on the bottom to make them cancel. And again, I've got feet, feet, feet on the top, so I need to have feet, feet on the bottom. So 12 inches over 1 foot, and then 12 inches over 1 foot. So I have all of this, and that is going to work. I'm going to cancel all the feet, 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 feet in the numerator, and feet, feet, feet in the denominator. And so that is all canceled, and I end up with cubic inches. So here are all the numbers I have. 16, and then I have 5,280 3 times, and then I have 12 3 times. Okay, and that's going to be cubic inches. All right, so we want to estimate the value of this product. So what we're going to do is we're just going to go ahead and estimate every single one of those numbers so that it only has one non-zero digit. So 16 is between 10 and 20. It's closer to 20, so I'm going to estimate it to be 20. 5,280 is between 5,000 and 6,000. It's closer to 5,000, so I'm just going to write 5,000. Okay, 12 is between 10 and 20. It's closer to 10. So for all the 12s, I'm going to put 10. And now I'm going to change all these numbers to scientific notation. So 2 times 10 to the 1 times 5 times 10 to the third, 3 times, and then times 1 times 10 to the first, 3 times, And now I'm going to multiply it out. I've got 2 times 5 times 5 times 5, which is going to give me 250. And then I've got 10 to the 1 plus 9 gives me 10, and then 11, 12, 13. Just adding up all the exponents on my tens. 250 is between 200 and 300, so I would write that as 300 because it rounds up to 300 because it's right in the middle between 200 and 300, and that's times 10 to the 13. And 300 can be written as 3 times 10 squared, and then you've got 10 to the 13. And so your final answer is going to be 3.0 times 10 to the 15th power. So here we have it. We're going to look at all the numbers and we're going to round them to the nearest number that has only one non-zero digit. So 3,728 is between 3,000 and 4,000. It's closer to 4,000. So I'm going to write that as 4,000. 470,165 is between 400,000 and 500,000. It's closer to 500,000, so I'm going to write that one. And then we also have 10 to the negative 14th. On the bottom, we have 278,146. That's between 200,000 and 300,000. It's closer to 300,000, so we're going to write it like that. Okay, so for this, since it's got a decimal point and it's to the right of the decimal, we're just going to look at the non-zero digits, 713, and we're going to think about what two numbers is that between. 713 is between 700 and 800. It's closer to 700, so I'm going to just rewrite that as 0.000700. And you know that when you have a decimal like this and you have some zeros hanging off the end, you don't have to write those, so you can leave those off. And then we have times 10 to the negative 5. So now all the numbers are rounded to just one non-zero digit. And so I'm going to write everything in scientific notation now. On top, I've got 4 times 10 to the third power. And then I'm multiplying that by 5 times 10 to the fifth power. And then I've got that 10 to the negative 14. And on the bottom, I've got 3 times 10 to the fifth times 7 times 10 to the negative 4, because it's a tiny number, and that means you need to write it with a negative exponent. You're moving the decimal from here to the other side, 4 spaces to the left. So it is 7 times 10 to the negative 4, and then we also have 10 to the negative 5. And now we can just multiply it out. 4 times 5 is 20. And then that's 10 to the 3 plus 5 is 8, minus 14 is negative 6. And then in the denominator, 3 times 7 is 21. And you're multiplying that by 10 to the 5 minus 4 is 1. Minus 5 is negative 4. And that's about, 20 over 21 is about 1. And then 10 to the negative 6 over 10 to the negative 4 is just 10 to the negative 2. And if I'm going to be picky about it, I would want to write this as 1.0 times 10 to the negative 2. Okay, let's look at one more. This one, again, we're just going to change all these numbers to just one non-zero digit. So for 0.018765, you've got this big giant number, 418765, and that's going to be between 400,000 and 500,000. And since it's 418, it's closer to 400,000. So I'm going to rewrite that as 0.04. I don't need to put all those zeros after the 4 because that you don't need to do that when you have a decimal. All right, so times 10 to the negative 14. And then you've got 41,725. That's close to 40,000. And then 10 to the 43. And then on the bottom, you've got 9,764. That's closer to 10,000 than it is to 9,000. So we're going to write that as 10,000. And then times 10 to the negative 23. All right, so now I'm going to write everything in scientific notation. 0.04 is 4.0 times 10 to the negative 2. We've got 10 to the negative 14. And we've got 4 times 10 to the 4th for 40,000. And then we've got another 10 to the 43 here. And then on the bottom, we have 1 times 10 to the 4th times 10 to the negative 23. All right, so you can notice that you do have a 10 to the 4th on the bottom and a 10 to the 4th on the top. I didn't notice that on the last one, but we had some common factors we could have canceled. All right, so after we do that, we have 4 times 4, which is 16. So 16 times, on the top, we have negative 2 minus 14 is negative 16, plus 43 is 27, so 10 to the 27. And then on the bottom, we just have 10 to the negative 23. This is going to be 16 times 10 to the 50th. And then we would want to write that. Well, first of all, 16 estimates to 20. So 20 times 10 to the 50. And then that would be written as 2.0 times 10 to the 1 times 10 to the 50. And so that would be 2.0 times 10 to the 51. So that is how you estimate with scientific notation. Please be sure to remember that on your test, you will not be having this kind of scientific notation problem. So when I give you a scientific notation problem on the test, you need to make sure that you do it exactly the way it is. Don't round it. This is just when you're estimating with scientific notation.